Hi, this lecture was focused on Lean software development. Uh, and why we started to discuss this, it is because Lean got so popular in other fields and the ideas behind Lean, they seemed so interesting that software engineers, they started to apply those ideas. And for us, what we need to do in this lecture is to understand the practices and the principles behind Lean methodologies and then Lean software development. And we did this by means of a game, and this game was created by Danilo and Francisco. And well, what is Lean? So Lean is the way that Toyota produces things. So the Toyota production system, and it in a way revolutionized the manufacturing. So if you compare the Ford way of doing things at the time and then the new Toyota way of doing things, they were quite different. And the ideas were nice. They started to be applied by many different companies. And there are lots of concepts. This is just an introduction. And the main ideas we're going to discuss, we discussed was push and pull systems, Kanban, systems thinking, flow, and work cells. So how we did this? I proposed you to come up with a factory of Lego houses. And this factory had 4 stages, or the 4 tasks in the slides, and the stage 1 does something which stage 2 uses as an input, stage 2 does something, produces something that stage 3 uses as an input, so on and so forth, until we have a house and we sell it at the end. And each team had its own task. They could not talk to each other, but if everyone does its job, we're going to have Lego houses at the end. Then you worked for a while, but then we didn't like the results that much. And what we saw is that we had some visible inventory. So we had lots of Lego pieces all over the different tables. We had over or under production. So sometimes we produced Lego houses with colors that we didn't want. Sometimes we had underproduction, meaning we didn't produce as many Lego houses as we need. So this is waste. And in a way, one way to see the Lean methodology is a way to fight the different wastes we can have in our process. If we go to the 7 wastes of manufacturing, as Lean puts it, we have overproduction, which is when we produce more than we can sell. And this is a waste, right? Because you're going to have something in there that costs you money. Imagine a car manufacturing. If you produce 1 million cars that you don't sell, where do you put them? You have to maintain them. These kind of things, they cost money. Waiting, the name says it all. If you're just waiting for something to happen before you can start working, this is a waste, right? And if you think of a very complex process, maybe you are waiting for pieces to come to you so that you can produce. This shouldn't happen. Unnecessary transportation. So think of an industry factory again. And if you keep needing to transport something from this part to that part that is quite far in the industry floor, this is a waste. Overprocessing means putting more effort on something than you need. In software, this would be like refactoring a lot, right? More than you need. Maybe this is a waste. Inventory, so having items in the system that you're not completely using, you paid for them, but yeah, you're not using, you have so many of them, lots of inventory can be a waste. Motion is about motion, and think about someone in an industry floor and this person has to keep moving all the time to do his or her job. That's a waste. And defects are defects, and we don't have to explain why this is a waste. And before the Lean system, we were very used to the push system. And the idea of the push system is we don't know how many people are going to buy our product, but we guess. So we're expecting some demand. And what we do is we just produce lots of our products, like lots of cars, and we get money because we buy the pieces for a very small price and we sell them for a higher price. So we have economies of scale, right? But the problem with the push system is that it is just very hard to adapt, right? Because you're building things without really knowing your demand, your customer. And what Lean tried to do is to invert this. So we produce something, on demand. So we know what we needs to be done and we build it, and what we gain from this is adaptation. And the pull system seems to fit better the software world, right? Because that's what we need, adaptation. Then we discussed Kanban, and Kanban is this physical device that helps us to see how our process is going. And we have many stages, many tasks that we need to do, and the Kanban lets us to know which stage is more overloaded, if the next stage has input to start working. So there is some sort of visual control that helps us to see what's going on with our process. Um, in this slide, I say signals demand to the downstream process, and this means, well, imagine that we have many different tasks. So in the factory, we had 4 tasks, and the process A, it is not working really because the buffer, which is something that process B consumes. So the triangles become this other figure. The buffer is full, process B is working, and process A doesn't have to work that much because the buffer is full. But at some time, process B will catch up. There will be a space in the buffer, and then this buffer having this empty position signals something to process A, which is, well, now you have to work, and process A works, produces something, and then you can use this information to signalize whether you should work or not. Then we went to this step 2 of the task, which was, let's just work based on the demand that we know. So if you pay attention to the figures now, the arrows are quite inverted. Now it starts from selling the house. We know we need to sell the house. Task 4 starts to work. This signalizes task 3 that they need to work, so on and so forth. You did it. It was a bit better, but we had now a different type of waste, which was the unleveled process. We had 4 tasks, and each group was, some groups were working more than other groups. And this is just a waste, right? In a way, we want the process to be leveled. Everyone working at the same pace, or just, producing in the same way, right? So that being said, our goal is to have a continuous flow. And how can we do this? How can we have continuous flow? One way to do this is to first think about the system, or systems thinking as they call. And the ideal is we need to understand what the system does, and we need to reflect about it. I need to know what other teams are doing. I need to understand what I am building, and etc. So we need to have some sort of consciousness about the entire process in our entire company. This wasn't happening in the game because so far the teams only knew what they do. They didn't know what the other teams were doing. So what we did in the lecture was that everyone started to tell each other what they were doing so that we can improve the system. In our game, the question was, do we need 4 teams to build the house? Probably not. Then the other concept we discussed was the work cell concept, and the ideal is we were very used to the waterfall model where we had one team doing requirements, and this team passes requirements forward to the architecture team, and the architecture team thinks about the architecture and passes on to the implementation team. But what Lean suggests very strongly is that instead of having different teams with different responsibilities, we have one work cell, and this cell contains people with all the skills we need to build our product. So one cell is responsible for the entire flow. If we take this to software engineering, one work cell contains people that know how to do requirements, that know how to do implementation, that know how to do architecture, that know how to do user interface, etc., etc., etc. This is a work cell. The third step of the game was to then have one work cell. These people define their process and they produce. But still, we were getting better, but there are things to improve. And then the final concept is the Kaizen, or continuous improvement, or the retrospective, as Scrum calls. And this is just a part of the process where you reflect and you adapt and you try to improve. we repeated this a bit, and these were the concepts we discussed about Lean. So pull versus push system, Kanban and work in progress. So remember that the Kanban can show us how much work we have in progress at that part of the system. Leveled process, we want to have a leveled process. And this is connected to the ideal of continuous flow, right? Then we went to the discussion of work cells, so a group of people, and they are completely responsible for the entire flow. Systems thinking, which is about understanding the system. And then the Kaizen, which is continuous improvement, reflection. So this was the Lean lecture. And now we try to do some correlations with Lean software development. And overproduction, we relate it to extra features. If you produce features that your user never uses, this is a waste. Waiting is waste. Unnecessary transportation, we moved it to task switching. So if you keep switching between tasks, this is unproductive. Overprocessing, we moved it to extra processes. If you have more, well, if your process is more complex than it needs to be, this is a waste. Inventory, we moved this to partially done work. So you didn't finish something and then you had to move to another task. That work that is not finished, this is a waste. Motion, although the book calls it motion as well, I prefer to be more explicit and say that inefficient information motion. So if you have to pass information through your different parts of your system and you do this in an efficient way, this is a waste. Defects are bugs and we don't like them. I pointed you to the chapter 1 of the Lean software development book, which gives basically, it describes the 7 wastes in software engineering. And then that was the lecture.